Welcome back to the Les Smith Show.
We're gonna real quick go over, go over this real quick on your formula list, because you need a formula list, Colton. This is really, the rest, they heard this yesterday and somehow it didn't get recorded. So I would put on there the quadratic equation, and you aren't gonna need it, well, you will fairly soon, but not right away, this chapter though. And in the book, they use V sub 0 and just V without that. Just that we aren't going to use that. We're going to use V1 and V2. And V1 is the original velocity. V2 is the final velocity. In a problem, we'll do some examples so you guys know what it is we're talking about. And we have, so far, we have the distance or displacement, depending what you're doing, equals speed times time or velocity times time. Distance is speed times time. Displacement is velocity times time. And we said that acceleration is a change in velocity. So what's the difference? V2 minus V1 over t. And we rewrote it as the same thing. Just rewrote it for V2. Solve for it. We got V2 equals V1 plus AT. If I put a box around it, it should end up on your formula list. All right, and then we went on to, we start from the same, the average velocity times time equals the displacement. And average velocity, like any average, we add up the two as long as it's constant acceleration. So this one doesn't go onto your formula list. That one will get you in trouble trying to use that one. But strictly speaking, if it is perfectly constant acceleration, if you add the beginning and the end velocities divided by 2, you have the average. And so we can put that in for the average velocity times time. And this is where we ran out of time yesterday. So if we rewrite that for time, t equals, and you can play along at home if you'd like to, t equals v2 minus v1 over a. Check that, make sure that I did my algebra correctly. I believe I did. And I'm going to substitute that in for this. So now I have d equals v1 plus v2 over 2 times v2 minus v1 over a. All right, and if you, what are you going to do with that? What does it look like we need to do with that equation?
Multiply them together.
And what process are we going to use to multiply them together? Foil. We're going to foil them.
Oh.
First, outside, inside, last. Give it your best shot there. Go ahead and foil those. The excitement is palatable in the room. Try.
Yes, I did.
What do you got? D equals.
I put v to the third. I'm already wrong, aren't I?
Generally speaking, yes,
Because
but
don't you take v1 times v2, like
I do.
first,
I do.
outer, inner, last?
Yep. That's exactly what I do.
So what did I do wrong?
You do that. Those two together.
Can you not combine the 1 and the 2?
No, it would be V1, V2. Oh, no, that doesn't turn into V3.
Oh,
That's just V1, V2.
Okay. Well, I know what I was doing. I just didn't do it right.
All right.
I see.
Too Young, what did you get for when you put them together?
I got V2 squared minus V1 squared over 2a.
I concur, and that is a good one. If you want to put that one in your formula list, it will work. It's usually written, just commonly it's in the form. This is the same thing Ju Young said, and she did it the way I had it written here, but the way it's usually done is V2 squared. Usually we're solving for what is the final velocity. If we know the first velocity and how far it went, equals V1 squared plus 2AD. But this one could be helpful if you're solving for the displacement. That one could be helpful as well. They're both the same thing. And she got rid of the middle terms, the V1, V2, because when you did the FOIL, you got V1, V2 minus V1, V2, so that just went away, which is nice. All right, now we're going to start we have one more to do. We're going to start from, oh good. From that place again. Okay, so we're starting from here. This is just average velocity times time. Displacement equals average velocity times time. Same place. But we also know that V2 equals V1 plus AT. You should have put that on your formula list already. So if we take that and we substitute that in for V2, that will get rid of V2. For each one of these, we are missing something. If we don't have it, we can still solve for. So this one, if we don't know the final velocity, we won't need it in this. We're going to get rid of it because we're going to use substitution principle from algebra. And you thought you'd never use algebra again. So D equals V1 plus V1 plus AT over 2 times T. This time we're not foiling. This time which property are we going to use?
Distributive.
Distributive. But first do that whole math thing and group like terms and then use the distributive property. And this one is generally written D equals, so. The nice thing about these is usually once you actually put them together, they clean themselves up fairly nicely. They don't stay as messy as they start. Get an answer for me, young man?
Hopefully. You do D equals T V2, is that right?
There is no V2 anymore.
Don't you add the V1 to V2?
That would give you 2
I did 2
V1.
Yeah.
So would it be 2v1t times t? You know what I'm saying? Like you
Yeah.
have the t on the equation, so t
To
v1,
V1
and then t
T
plus, and
Plus.
then a t to the second,
T squared.
yeah, and then over t, 2t, right?
Oh, this just goes up here. We don't
Oh.
distribute down here, so it's just over 2.
Okay.
Okay? And that's, you don't put, I'm not putting a box around this. Everything he's done here is correct, but he's not finished. It's just, this is one of those where you get partial credit in math class because you gotta continue with it, so.
Don't you have to simplify it by taking away the 2's? There's a 2 on top and a 2 on bottom.
There is, but this 2 goes here and it goes to this
Oh,
2. I can't just
right.
cancel it here and forget because there's a plus. If this was in times, then I could. So, but what you're saying is true. I can rewrite this as 2v1t over 2 plus a t squared over 2. That is the same thing. I just have them now, they both have this, and now I can cross that out. And you could write it like this, but often it is rewritten as d, probably not the easiest for people to see, d equals v1t, because you're right, the 2 has disappeared there, plus, now we bring everything up and we just say 1/2 a t squared. D equals v1t plus 1/2 a t squared. Which again, coming from where we started here, this cleans up fairly nice. That's not too bad. But here we have displacement v1 and t and the a. We have a in all of them. In the last one, we didn't have t, we didn't have the time, and the first one we didn't have displacement. So it all depends on what you know as to which one you're actually going to use. All right, those are the basic kinematic equations that we're going to use. Now we're going to do a couple of problems to show you how to use them. How do I know which one to use? How do I go about doing this? And then you're going to be excited because I will put some new numbers up on the board. And they can't hardly hold themselves back. Do we really have to practice? Just give us the chance to go. But it'll help if we go on our own. All right. I'm just going to do examples out of your book. Here we go. How long does it take a car to cross a 30-meter wide intersection after the light turns green if it accelerates from rest at a constant 2 meters per second squared? All right, so we have car at an intersection,
Wow.
and here's our car. Going in this direction. And the first thing we do is we write down what we know. What do we know about this car? Let me read it again. How long does it take a car to cross a 30-meter wide intersection after the light turns green if it accelerates from rest at 2 meters per second squared?
It's going 2 meters per second.
It's a,
Okay, so the A, that's the acceleration. And let me go through that real quick. 2 meters per second squared. What does that mean? Meters per second squared. What it means is the actual way it's written as 2 meters per second per second. So every second that it's going, it's speeding up 2 meters per second. But we don't like to say 2 meters per second. or even write 2 meters per second. It's easier to write 2 meters per second squared. Anytime you have a distance over a time squared, that's an acceleration. Now it could be, if this wasn't in meters, they're starting off nice and easy, where they give you everything in meters and seconds, but it could be 2, this is pretty slow acceleration, but 2 kilometers per hour per second. And then there's no shortcut, but that actually makes sense too. Every second that it's moving, it's speeding up 2 kilometers per hour. After the first second, it's going 2 kilometers per hour. The next second, 4 kilometers per hour, 6 kilometers per hour. Every second, it's going to be going 2 kilometers per hour more. This time, it's going 2 meters per second faster every second. So 2 meters per second squared is how fast it's speeding up. How do we know it's speeding up? Or how do we show that it's positive? We'll do one where it's slowing down. It'll be a negative number. Okay, what else? Let me read it again. You guys, you have this problem on page 30. Okay, so this is 30 meters, and they give us 3 sigfigs on that one. That's nice. 30 meters from there to there. That's a big intersection. It's nice. And they give us one more. We need one more. Let me read it one more time. How long does it take a car to cross a 30-meter wide intersection after the light turned green if it accelerates from rest at a constant 2 meters per second squared? This is one that students often forget, and it's impossible to answer the question without it. If you are a good law-abiding citizen, which I'm assuming all of you are, you came to a stop sign, so you stopped. So what does that tell us? We need one.
0 miles per hour.
What is that?
0
I want to write 0. What is 0?
miles per hour.
Or meters per second. 0 doesn't need units, but what in our formulas, what is that?
Can I keep this in here for a bit?
Yeah. Boom, boom, boom.
Is it a
Wait,
velocity?
we got to get a little bit more aggressive on that bass. I want to hear you dropping some sweet riffs on that.
Sweet riffs.
Yeah.
Is it velocity?
Thanks, Mr. Schmidt.
Yeah. Which velocity? 1 or 2?
It's 1, right?
1. That's what we're starting at. You have to start at 0, but we can't answer the problem. This is the displacement, is that. And it could also be the distance in this case, because we're going in a straight line, the distance and displacements can be the same time. So I know A, V1, and D. Now go to your toolbox, your formula list. On your formula list, oh, and the other thing we need to know is we want to know time. So what formula has D, V1, and A, and we're looking for time?
D over V time. It's V sum. The V. What's the V called?
Velocity?
Velocity has like a line over it.
That does, but that's average. We don't know the average. We know that we start at 0. We have no idea how fast we're going at the end. We're going to have acceleration in there somewhere. It's got to have acceleration.
V2 minus V1 over A.
Yes, about it.
It does, but we don't know V2.
Wait, would
JC?
it be the V2 equals V1 plus A?
We don't know V2. I mean, I suppose we could calculate V2. We like to do it in one step, though. Oh, except we don't know the time. That's what we're looking for. That formula you were going to give me, we have to know the time, and that's what the question's asking us.
Oh.
We don't know V2?
We don't know. And I'm going to answer the problem without ever knowing V2.
Just guess.
No, I don't just guess.
I don't know.
Do we have this written down? Or?
You do. You need one that has D, V1, A, and T in
Is
it.
it the big one?
don't know which one you call
V
it.
Is it
equals
V1?
Yep, so if we do D equals V1T plus 1/2 AT squared, and we're gonna solve that for T. And the first thing you should do is, oh good, I get to use the quadratic. No, but then you think, oh, just as JC already saw ahead and she said, oh, no, we don't. Because I know that V1 equals 0, so if I put in the 0 for this, that whole section just drops
Yes.
out. So now it's just D equals 1/2 AT squared
Nice.
equals 1/2 times A, which is 2, times T squared. Oh, and I know what the D is, so I can put it over here, equals 30. Wow. Yeah, and I can even do some more math on this. 1/2 times 2, I'm fairly sure is 1, times T squared is just T squared equals 30. To find out what T is, I'm going to take the square root of both sides. T equals, my, 5 point, and do they give me, oh, they do give me 2 here, 2, or another one here. So 5.48 meters, I mean seconds,
Oh.
which is, that's not going very fast. If it takes you
Yeah, that's.
5.5 seconds to get through an intersection, that's being very cautious.
And what's
1
the,
second.
it's 5.48 what?
Seconds.
Half a second. I
Oh.
said one as soon as it turned green. I said
Yeah,
one.
that's a bad idea.
Thanks.
Yeah, it is. Always
there might be-
let
well-
somebody else take a breath.
But there might be
What?
someone speeding the right.
Yes, there's a
Yeah.
lot of drivers that think that, you know what, it's just barely turned red, I'm gonna go through, and then
Yeah.
you're just bumper bait.
My mom always tells me to step on it. It's funny.
All right,
Shush, man.
not often, but I'll say, don't, just chill a little bit, don't listen to mom.
If
right?
you need T, why do you have D equals, I think you need the T equals on the outside, you know what I'm saying? Like, this is D equals and you want
You know what I'm
to.
saying?
D equals, this was starting here,
Yeah, but you said on that side we need T, so I thought it was.
V1T plus 1/2 AT squared, and this is, that's what I'm looking for, that's what I want to solve for. I mean, I could solve for this one too, and if I had to, if there was a V1,
Yeah.
then I would have to,
I was just
enjoy
confused
that.
because I thought you said you wanted T, you were looking for T, so I was looking for a T equals.
well, I can, and that's actually the way I would do it. If I want to move the 2 over here, that would be 2D, and divided by A equals T squared, and then I can take the square root of that to get rid of it. It's just that this seems so convenient to take 1/2 of 2 and just get rid of that whole part of it there, but you'd still get this. You get 60, the square root of 60 divided by 2 equals the square root of T squared. I get the square root of 30 equals T. I'm going to end up with the same thing. I'll get it, so I can solve for that. That's the way I was taught to do it, that you always manipulate the formula first into solving for T equals the square root of 2D over A, and then put the numbers in. I guess most students do, so I'm going to guess the teachers are saying go ahead and put the numbers in first, and then work it out. I like it the other way, but that's just because I'm old.
What's
All right.
the assignment?
Now, how long do I get? How long do I get?
You have 3 minutes left.
3 minutes. I might not get to an assignment today. Oh, I know.
That's the worst.
We don't-
I know it is.
I
In
just
fact,
can't even believe it.
I will start with,
Gianna, I
So
wanted
let
an
down.
assignment, didn't you?
Oh, of course I did.
I was really hoping for one today.
Well, that's all to say, I guess.
Is there a main
Set to
equation
say.
usually used for most of the time while doing velocity? Or is that
Right.
it all
It'll be one of these, yep, and you'll get used to using the different ones and
Okay.
that. All right, we'll do one more example tomorrow, and then I will give you an assignment, and you will be able to work on it, and then we will,
Are we having class tomorrow? In the
Oh,
afternoon?
yeah, are
How
we?
many periods do we have in the afternoon?
Oh, isn't it one
oh,
through
wait a
four?
minute.
We have to do
Yeah, no, it'll
Friday.
be on,
Oh,
it'll be on Friday.
is it the last?
Game day.
Is it the last periods of the day? Is that what it is?
Yeah, you'll do
Well-
testing, and then it's 1, 2, 3, 4.
You test in the morning and then go to 1, 2, 3, 4?
Yep.
Okay.
This morning class.
That's weird.
Yep.
Wow.
All right.
So we're testing.
What a day. Who exists?
Cow.
Yeah, there's pictures on the internet.
Nice.
Oh, you can check that out.
Believe everything on the internet.
Like Reese Strawberry.
The
All right.
Oh,
Smith
yeah.
Show.
All right, well, welcome back. We are doing another problem here, and the class has set it up. We're just going to solve it now. We have a 2019 Shelby Mustang, and Colton thinks that sometime in his future he's going to have a classic Mustang.
Oh.
Yeah,
He has a Mustang.
well, his dad does. He's hoping. He's
His
hoping.
dad gave it to him.
Oh, he did? Congratulations, Colton.
Congrats.
2019 Shelby Mustang GT500 is traveling at 80 miles an hour, and then we didn't write all of it in there. It sees that further down the interstate, it sees a cow in between the lanes, and it's a little worried that it might wander out in front of the lane that it's in. So the driver wisely slows down to 25 miles per hour at a rate of 12 meters per second squared. The two questions we have to do is how long does it take, that will be in seconds, the time did it take to slow down, and how far did it travel?
Obviously, I know the velocity and the final velocity. V1 and V2. Stuff to know.
Gotta know more than that.
And you know you can do T equals V2 minus V1 over A because we have all that information.
Yeah, because we also know A. A is the
Oh,
12
meter. Okay.
Okay, so
Oh.
now I'm going to take, and I don't have any room, this wonderful problem takes up all of this space, so we can look at it again if we need to, but I'm going to put it up here for reference. We can make it bigger again. So what we know is V1 equals 80 miles per hour. We know V2 equals 25 miles per hour, which in this case, probably on the interstate is just as dangerous as the 80, probably more so. Somebody going that slow, another car coming that is that, but the cow might step in front and actually save you from somebody hitting you from behind.
So you know how she said that it would be T equals V2 minus V1 over A? So are we switching it to D equals V1 plus V2 over 2 times T?
Well, first time we're just looking for T.
Oh,
The first
okay.
A is just looking for T, but right now we're just getting this because we have a problem with this, because in our original problem, I want to know in seconds, and this is miles per hour, and I have the accelerator, well, I guess I should get that too, acceleration. That. Acceleration equals, what is the acceleration?
12.0.
Are you speeding up or slowing down?
Slowing down.
Slowing down. How do I show that we're slowing down? I would. Negative. Anytime you're slowing down, you put it as a negative. If you're solving for acceleration, then don't be confused with, oh, I'm getting a negative number. Well, you better get a negative number for acceleration if you're slowing down. So it should come out as a negative number. So negative 12 meters per second squared. Now, I immediately see that there's a problem here, and I knew that there was going to be. That's why I kind of let you guys set it up. So you can see I've got miles per hour and meters per second squared. Can't do that. Can't have miles and meters, and that they all have to be the same. So the front of your textbook, we've got to turn miles per hour into meters per second.
There's
Gross.
1,610 meters per mile.
Right, but you can go right to speed. You can go right from, they have a conversion for
Yeah.
miles per hour to meters per second.
0.447 meters.
You're gonna need a calculator because it's not, that doesn't give us anything. You have to do something with
I
this.
know. I'm just telling you.
Oh, I know.
Multiplying it by the 25, like for the first one, and then you multiply the other one by 80.
I think you just take we're gonna do 80 miles per hour. And then it says the factor is to go from miles per hour to meters. How many meters per second is there?
0.447.
Times
That's
0.447.
what I was trying to say.
And then you'll do the same thing, 25 times 0.447. And we get 3 significant digits. Our answer gets 3. We're going to have to round this. So the key is always take at least one more. Now, if you can just leave it in your calculator, you're not going to be able to in both of these because you have to do 2 of them. But since we get 3, take 4. So, and then we'll round it down at the end. So
35.76 for 80 times 0.447.
So what did you get?
35.
Oh, 35, okay. 35.76 meters per second. And for 25?
11.18.
All right, so we have to make sure that our units are agreeing. So that's one of the reasons that I was worried about any answer you were going to give me, and I was also a little concerned, JC, that you weren't going to have a negative there. All right, so now I can put, and I know V1, V2, and A, and I'm looking for A, I'm looking for T. What is the time? So depending on how you have it written, usually that one is in the form of V2 equals V1 plus AT. But as you go through these, if you rewrite that, it's okay to go ahead and put that the new way that you wrote it in there. So if I solve this for T, T does equal V2 minus V1 over A. And that's what we were talking about. That's the way I was taught to solve this. Solve for my variable first, rewrite my formula, and now put in the numbers. So now I'm going to have V2 is 11.18 minus 35.76 divided by negative 12.
You're going to get a negative.
I am on the top, and that was going to be a problem for JC if she hadn't put a negative here.
At the bottom.
She would come out with a negative number. And a lot of students just think, oh, well, it shouldn't be negative, so they just drop the negative. Unfortunately, this time, apart from the fact that she wasn't using the correct units over here, you actually could. You could just drop the negative, but most of the time you can't. There is no such thing as negative time. You can have a negative acceleration, you can have a negative velocity, you can have a negative displacement. You can't have negative time. We can't go backwards in time.
Not yet.
So you get 2.05 meters per second. Is that right?
Yeah, we're looking for time.
Oh, 2.05. I mean, that's T.
Okay. Everybody concur with that? And who is actually? She's the only one that's actually got a calculator out here. Right, I know, but so we're checking. I don't have it. We just made this up. I don't know what the answer is. I know 12 is a huge number for slowing down, but okay. So this is more than 1 G. We're going to talk about a G is what you're experiencing regular, and this is more than just what gravity is. So this would be huge. this guy, he stepped on the brakes pretty hard. I mean, you're slowing down fast. There's blue smoke coming up from the tires, and it's probably swirling a little bit, and hopefully that is going to chase the cow. Maybe it runs the other way, hopefully not in the lane of somebody going the other direction. But that would be seconds. Make sure that you put a unit on it, and you put a box around it.
You slam that hard.
So you're going 80, and then
That's
1
so
and
fast.
2, and you're doing 25. Yeah, that's.
Is that possible?
Oh, it's possible, but that's fast.
That's insane.
Let's
Yeah.
try it as an
There's like-
experiment. The tire and pink cow.
All right, but you see, you've got all this other stuff here. As the teacher, I don't want to go look through this. They have a 2.05 here somewhere. Make sure you put a box around it. I want to be able to see where you're doing it.
Easy.
All right, and whoops, I don't want that actually in there.
Oh, that's a lot of boxes.
That is a lot of boxes, but you know what? Now there's only one.
Nice.
So, whoops, I go this way. Okay.
Wow.
Nice.
There's A. Now we can do
Well,
B.
yeah, it's so-
Oh my goodness, which one?
B. Now, there's two different ways you can go because now we still know V1 equals 35.76 meters per second. And we know V2 equals 11.18 meters per second. And we know A equals negative 12.0 meters per second squared. We still know that. We think we know that that's the time. But I didn't give that to you. You calculated that. And I trust you because Ju Young corroborated it. So two of you do it. I think it's true. But you still, it's a calculated number. Sometimes you have to use that. Sometimes you're going to have to go through, ooh, I need the time. I'm going to have to calculate the time first and then put it in. Sometimes you have to. If you can get the answer without, you're better off. Because if you got this one, you got part A wrong,
You're gonna get part
you're going to get part
wrong.
B wrong. And you just, depending on the mood of your physics teacher, then I'll give her partial credit. I don't know, man. He should have. Nah. Or it's wrong. Depends on, so let's eliminate that whole grumpy teacher thing. And can we get the answer, can we get D without using the T? And the answer this time is yes, we can. Because we have a formula that says V2 squared equals V1 squared plus 2AD. No time in that one. And we know everything else. So again, I will do the boomer thing and solve it for D first. D equals, just do the algebra, V2 squared minus V1 squared all over 2A. And I'm just going to let you know right now that the things that students mess up the most, and this goes back just not as long as I've been teaching, I was sitting where you sat at one point, and the silly mistakes that I would make, not squaring, and the 2. You just do like we did over here, and you just divide it by A instead of 2A, and your answer will be exactly twice what the right answer should be or what other people are getting. So if all of a sudden you've got double for the distance, a lot of the times, oh yeah, I forgot to put the 2 in there. I don't know why it's sitting right there, but I, myself included, I would often forget that. So D equals 11.18 .18 squared minus 35.76 squared, all over negative 24. I did that one.
I got 48.07.
Okay, this might not be realistic. I'm not sure that your Mustang can slow down at 12 meters per second squared, because I don't think you're gonna go from 85 to 25 in 40 meters, that's right. What did you get?
48.07.
So 48.1
Yeah.
meters. Get the unit on there. We'll see, we're about to get that checked here, see if we agree.
Are you checking
We're waiting. Patience is our thing.
Let's go test it.
Oh, I plugged it
It happens. That's why we call them silly mistakes.
Happy little
in. They're not so happy.
Not on tests. No.
That's right.
Okay,
Wow, that was an unbelievable.
What was
problem.
B?
that was, you know what, and some of the problems that you get from me will be, most of the books is gonna be pretty realistic. Sometimes mine are kind of fanciful as well.
Yes, I like those.
Most of the time, they are, so you can check and you think, that's crazy, that's not, I mean, 50 meters, that's most of your football field or whatever, but slowing down from 80 to 25. Now, it might be possible with some of the sports cars and stuff that they have. Shelby does a pretty good job of preparing those. They put on huge brakes on those, and with the new anti-lock brakes, because you're not going to lock them up and stop it that fast. You're going to have to just slow it down, but that's pretty good stopping distance from 80 to 25 with that. All right, the assignment, where is it? Here it is.
Uh-oh.
Oh no, oh good, oh good.
Oh yes, my favorite.
Not bad.
That just tickles me.
Ouch.
Please don't give us a lot of problems.
I think you left hold on.
Colin's still watching.
Yes, no, he is. He's got to get the assignment too.
He's like, come on, Mr. Schmidt, give me the assignment. Get to the point. Sounded like fireman class.
Yeah. You'd be like, oh, I'm glad I'm at home. Just give him a neat house.
All right, let's not go too much here. Whoa.
Whoa.
That was fun.
That was us. We had fun.
Yeah, that was fun.
That was us. Page 43. And this will migrate over there, but page 43, not too many. 13 through 15, comma.
Oh, yeah.
Oh yes, we love commas.
18 through 21,
Oh.
bonus.
Oh.
30, but you gotta show your work. You can't just give me an answer. You gotta explain why
Trust
that's
me.
the right thing to do.
How much is the bonus worth?
Enough.
Okay.
Okay, so that's only 7 questions. And 1, 2, 3, 4 of them are odd numbers.
Nice.
Yeah, so you'll
That
be able
means I
to
can
know.
Check it in the back of
Mr.
the
Schmidt?
book.
Yes.
What it says, it starts from, like it says when it says a sports car accelerates from rest to 95 kilometers an hour, is the acceleration 95?
No. That's V2. That's how fast it's going at the end. What's V1?
That's the original.
Which is?
You don't know V1.
I do.
Oh, 0.
0 from rest.
Oh,
It's
yeah.
0.
So
And then V2 would be, no, yeah, V2 is 95.
Sort of.
That's not the final velocity, though, is it?
It is. It is in kilometers per hour. But you're not going to want it in kilometers per hour. You're
Yeah.
going to
It wants it in meters. Meters.
be nice to my table, Miss Young.
Meters per second squared.
Okay, so
6.2 seconds.
to get meters, if they give you kilometers per hour, remember to turn that into meters per second, you're just going to divide it by 3.6 and that will give you meters per second. That should be on your formula list.
So the time would be 6.2 seconds, right? Is that time?
Yes.
Okay, so you know time too.
All right.
Okay, let's try it.
Any questions, Colton? You can send me a pen, or in Canvas, there's some kind of a message. I haven't really got great at that yet. Or you can email me a question, but that's it for today. Unless you want to watch the Ju Young and JC show over there.